Hello everybody, welcome back to the LMS initiative of Department of Collegiate and Technical Education. So we are now into the 7th session of Particulate Technology course. So before we start discussing the topics for today, let me just recall what and all we have learned in the previous classes that makes you understand the concepts that we are discussing today. So this was the course objective that I told you in the starting class. So the objective of studying this course for a chemical engineering student is to make him understand the principles, analyze, differentiate and explain the various equipments in particulate technology field. So before we recap the important points we discussed, so this is the course outcome for studying the first unit. So you should be able to understand the laws of size reduction and illustrate the operation of various size reduction equipments. So that is what you are going to attain after finishing this unit. I am repeating the course objective and outcome here today because I don't want you to forget that. So each and every class should be learned with the same objective. ಸೊ ನೀವು ಮರ್ತೋಗದೇ ಇರಲಿ ಏನು ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಅದಕ್ಕೋಸ್ಕರ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. So a quick recap of what we discussed in previous class. So we studied about gyratory crusher, its working principle, its construction, then its application. So then we compared the two important crushers, the jaw crusher and the gyratory crusher. So how they are different with regard to operation, advantages and disadvantages. So then we also studied the other crusher, that is roll crusher, its construction and working. So now we have finished learning about the crushers. So now it is time to take up the next category of size reduction equipment, that is grinders. So just recall and tell me, what are grinders? So what is the difference between a crusher and a grinder? So crusher are the size reduction equipments that reduce the size of very big particles to smaller size particles. That is, they are basically the machines employed for coarse reduction of hard solids. Then the grinders are the intermediate size reduction equipments, means they are used for an intermediate duty, means they are coming in between the crushing equipments and the ultrafine grinders in the order of the categorization of various size reduction equipments. So intermediate duty means where the machines take feed from a crusher and reduce it to fine size. So basically grinders are those equipments which convert the coarse particle to fine particles. So the important topics for today's discussion is grinding equipments, and under that the first one, the hammer mill. So let us understand its construction and operation. So this is what is meant by grinding. So grinding basically is an operation where the solids are reduced to finer sizes. It is a coarse solid are taken to fine, are converted to finer sizes in grinding. So they usually take feed from a crusher. So they are used for an intermediate duty, that is a duty that lies in between the crushing equipments and ultrafine grinding equipment. So they are charged with the product that is obtained from a crusher. Okay, so the important grinding machines that we are supposed to study in this particular unit are, one is hammer mill, the other one is revolving or tumbling mill. So in today's class, let us understand the construction and working principles of hammer mill. Okay, this is a simple line sketch of a hammer mill. The hammer mill essentially consists of a high speed rotor that is turning inside a stationary cylindrical casing. So rotor is the main part along with the swing hammers. So the hammers are the grinding elements in this particular type of machine. The rotor is mounted on a shaft which is at the center of the cylinder. The shaft is horizontal. The swing hammers, as I said before, are the grinding elements in this machine. They are pinned to rotor discs. The hammers are usually rectangular bars of metal, either with plain ends or with enlarged ends. So these are the grinding elements, means the hammers are the one which are applying the required pressure on the material to be reduced to smaller size. So the particles are mainly broken here by the swing hammers, a set of swing hammers. So after having gone to a reduced size, the particles will fall down, and from the bottom there is a screen from where they get discharged as product. Okay, so look at the diagram again. The feed enters from the top, and when it comes inside, it is broken into smaller size by the swinging hammers as the rotor rotates, and when they are reduced to the required small size, they escape from the screen or the grate that is provided at the bottom of the machine. So that is a simple construction of hammer mill. So coming to its principle of working, so you all know that grinders are mainly employ impact and attrition as a force for reducing the size of the solids. So in the same way, the hammer mill employs impact and attrition force for affecting size reduction of the given solids. The material to be crushed enters from the top opening. Then the shaft is rotated at high speed, which in turn rotates the disc along with the swinging hammers at a very high speed. The hammers swing out radially during this rotation, so they impact a great force on the material that is coming from the top, so they'll be crushed to smaller sizes due to impact. So just like I said in the previous slide, when they are reduced to a certain size, they are small enough to come out from the bottom screen, so from where they are discharged as product. So coming to the specific applications of hammer mills, they are employed to reduce the size of tough fibrous solids. You know what is the problem with tough fibrous solids, no? They are resistant to impact. So a greater impact force is need to be applied on such a type of solids. So that is done in hammer mills. So tough fibrous solids like bark of trees, leather, steel turnings, hard rock, then sticky clay, all those materials can be ground in a hammer mill. Okay, this is another simple sketch of hammer mill where you can see that the rotor is rotating inside the casing and the feed enter from the top. So they are radially thrown out by the swinging hammers and getting reduced to smaller size and finally coming out from the bottom of the casing. So you can see the big dots at the top of the machine indicating that the bigger size particles are entering. They are getting reduced to smaller sizes inside the casing. From the bottom, they are going out when they are reduced in size into the required size and thereby coming out as a product from the bottom. Okay, this is the diagram showing the 3D view of a hammer mill. So you can see that in the right side of the slide, the outer view of the hammer mill. So there at the top you have the inlet, then there is a crushing chamber. So when you remove that top half portion of the casing, so then you can have a look at the parts that are inside the machine. So in the left hand side you can see the inside parts details. So you can see the discs, then how the swinging hammers are pinned to the discs. Since the hammers are pinned to the disc, the wear on the swing materials is less here. Okay, this is another pic showing the diagram of hammer mill that is used in a industry. So you can see the hammers here. So these are not plain hammers. You can see that hammers are provided with the enlarged ends. Okay, so that completes hammer mills. So now we'll take up the other type of grinding equipment, that is revolving mill or tumbling mills. So as the name itself indicates, these mills revolve during operation, so whereby the tumbling action takes place, that is the contents of the revolving part of the machine causes the solids to tumble about inside the machine. So basically these consist of cylindrical shell that slowly rotates on a horizontal axis. This cylindrical shell will be charged with grinding medium to about half of its volume. That is, half of the cylindrical shell is filled with grinding medium. The shell is usually made out of steel and it should be lined with the abrasion resistant materials such as manganese steel or ceramic or rubber to reduce the wear on the inside part of the machine. The grinding medium is usually made of materials like flint, ceramic or metal ball. It may be either ball, pebble, tube or rod that are used as a grinding medium. So whenever a revolving mill utilizes balls, metal balls, ceramic balls, etc. as a grinding medium, it's called as ball mill. So tube mill is similar to ball mill, only with a difference in dimension. So usually a tube mill will be long in length In fact, its length will be twice its diameter. Whereas for ball mill, the length is approximately equal to its diameter. That is how tube mill differs from a ball mill. So then if the grinding medium is a pebble, then it's called pebble mill. Then if you are using grinding medium as rods, then it's called as rod mill. So accordingly, the name changes. The grinding medium that is widely used in a ball mill is steel balls. Okay, we'll take up each one of this in the next session. So these are some references, the links which you can use to watch the construction and working of the hammer mill that we have discussed today. So thank you for listening. Thank you.